So good morning all of you. So today we are going to discuss about deep feed forward networks. So to understand this topic, you have to know about artificial neural network. So what is the architecture of artificial neural network? So before that, what is neural network? So neural network is a mathematical model, so which is working with the mathematical functions. Okay, so that is the neural network. So artificial neural network. So here, so how the brain is working is similarly or a simulation of brain. So we are developing the neural network. So this is the architecture of neural network. So you can see input layer, hidden layer, and the output layer. So the same you can explain here inputs. Okay, so how the inputs will be taken, x1, x2, and so on, xm. Okay, these are the inputs. Okay, x for input. Okay, weights, the input neurons consisting of the weights W1, W2, and so on, Wm. Okay, so this all at sigma. Sigma is the sum. So here B for bias. Okay, so this is the architecture. In this neural network, we are using the activation function. So this is the pi. So activation function. Finally, we are getting the output. Okay, so this is the architecture of the artificial neural network. So if you know this, you go for deep feed forward networks. Okay, so here already we have discussed in the previous topic, so what are the different types of deep feed forward neural networks. So it is one of the deep feed forward neural networks, one of the type of deep neural networks. Okay, so first we will see the introduction. A deep feed forward neural network, also called multi-layer perceptron. What is that? Multi-layer perceptron. So we can also call it as multi-layer perceptron. Is the simplest type of architecture neural network. If you see the architecture, so it consisting of the simplest architecture. Okay, that is the first point. Second point, what is the goal? Is to approximate a function f star that maps an input x to an output y. So here, we are taking the how to take the input function. So we can see in the architecture. Okay, second thing is you have to define the function, activation function. Next, information flows forward from input to output. So how the information will be flowing or passing or processing. So from input to output. So without loops are the feedback connections. So that is the main point. Without having loops are the feedback connections. So these are the main 3 points about the deep feed forward neural networks. So coming to the architecture. So here, if you see the architecture, so you can see here feed forward neural network consisting of the input layer, output layer, and hidden layers. Number of hidden layers to be taken. Here we have taken one hidden layer and the hidden layer 2. So we can see a deep feed forward neural networks consist of input layer. Okay, so receives input feature x1, x2, x3, and so on xn. So these are the input neurons. Okay, so these neurons consisting of the weights. Next one, hidden layers. Hidden layers. Okay, what the function of hidden layers? Perform transformation. So transformations using weights, bias, and activation function. So in the hidden layer is very important here only. So processing will be done. So how the processing will be done with the help of weights, bias, and activation functions. Okay, output layer. What is the function of output layer or the role of output layer? Produces the final prediction or classification result. Okay, so the output will be given. Okay, so each neuron computes. So we can take the formulae. So a of j equal to f of sigma I. So wij x of I plus D suffix J. So here where so Wij weight between neurons. Okay, if you know the abbreviations of this, you can understand the formulae. B suffix J is a bias term. Okay, see here bias. So we have seen this is the bias. Okay, so next F activation function. So here we can see activation function. We are taking the activation. So we are taking the examples ReLU, sigmoid and tan H. So ReLU is nothing but rectified linear unit. So this is the basic activation function. So we are using, or normally we are using, so ReLU is the activation function for general purpose. Okay, so depending upon the application, so we can change the activation function. So this architecture we have seen. So you want to understand about the deep feed forward neural network. Is a type of neural network where information travels in only one direction. Here so you can see that, so what is the deep feed forward neural network? Forward, so only forward direction only, so there is no loops under the so feedback. So from the input layer through the one or more deep hidden layers to the output layer, so with no loops or cycles. There is no loops or the cycles. Already we have discussed. Okay, again we are discussing, so to understand better way. So these networks learn to approximate complex functions by transferring data through a series of layers. With each layer, so learning increasingly complex features. Okay, the deep aspect refers to having multiple hidden layers. Deep is nothing but, you have to keep that in mind, so multiple hidden layers. Deep nothing but, so multiple hidden layers. And the network uses an algorithm like back propagation. Okay, so back propagation algorithm is very important in a deep feed forward neural networks. So for what purpose means? So in order to calculate back propagation is the process to calculate the weights of the neurons. That purpose we are using the back propagation in the hidden layer. So to learn from data by adjusting its internal weights and biases. Okay, so for what purpose? So internal weights and the biases. So learn from data by so adjusting its internal weights and the biases. Okay, those are the main thing. Working principle here. So forward propagation, input passes through layers producing output perceptrons. Okay, that means the predictions. Okay, output predictions. So here, so forward propagation means input passes through layers, so producing output predictions. We are going to predict the output. So loss function, what is the use of loss function? Measure the difference between predicted and actual output. So you never forget, loss function is simply so difference between the input and output is called the so error. Okay, or the loss function will be given the result, that is the error. Okay, mean square error or the cross entropy loss, okay, will be used in loss function. Next backward propagation, back propagation, so adjust weights to minimize loss using gradient descent. Understand? So here we need to adjust the weights. What purpose means? If error if you get from the loss function, the error is to be minimized, so that we need to adjust the weights. Okay, by adjusting the weights only can get the so accurate output by minimizing the error or removing the error. Okay, so here activation functions. So these are the activation functions have been utilized, sigmoid, tan H and the ReLU. These are the activation functions and advantages. So we can see the advantages of deep feed forward neural network. So can approximate any continuous function. So efficient for classification regression tasks. Regression task means prediction only. Okay, easy to implement using frameworks like TensorFlow and the PyTorch. Okay, so these are the advantages. Thank you.